Hey guys, and welcome to part two of what I believe are the three most important concepts for beginners to understand and really master inside blueprints. So, in the first video, if you haven't checked it out, I'd really advise checking it out. We went over custom events, and that was really the basis of code, the foundation. It was where do we call things and how do we call it. So if we open up like our cube, on tick, we were calling our spin function, and inside of our spin function, we were rotating it and we were spinning it. So at the start of the game, on event begin play in our level, we spawned our cube, and then on event tick, we were spinning our cube. So that was the basis that we worked with. The next thing that we're going to work with are actor references, or what are some called like object references. I mostly just usually lump them all into actor references. I just kind of stay vague like that. But really, what actor references are is they are references that we can use to help blueprints communicate with each other. So the best way to exemplify this is that if we open up our level blueprint where we spawned our cube before, all we were doing is that on begin play, we were spawning the actor of cube, and the cube was our actor here that we just looked at, where on event tick we were spinning it. So what happens when you spawn an actor or you create a widget, whenever there's spawning involved, 99% of the time you get a return value. And if we look at our return value here, if we highlight it, you can see it says cube object reference. And what this is that this is an actor reference specifically to our cube. And I think the most important distinction to understand is that this actor reference isn't going to be to every cube actor in the level. Like if we dragged in like 6 cubes into the level, that actor reference isn't going to be to every cube. It's going to be to that specific one cube. So I think it's really important to make that distinction. When we have an actor reference, it's not to every actor, it's to a specific one. And with this reference, we can manipulate it. In the previous video, I quickly showed that we can set variables inside of that other actor. If we look inside of our cube actor, you can see we have this boolean called spin. With this reference, we can manipulate that boolean. We could set it to be false on spawn. We can call the events. If you remember, we had a spin event and a spin function. We can call those events or those functions from this actor reference. So you can quickly see probably how this is really powerful. This is how we can then, not all of our code has to be encapsulated inside of our cube actor. We can have code somewhere else. We can manipulate the cube elsewhere. We can do things with it, and I think that's really powerful. And usually what I do with actor references when I want to hold on to them is that I promote them to variables. So what we can do with this alpha var return value is that we can promote it to a variable, and we can call this our cube reference. Now what we can do, since we have this reference, let's actually start our game and we'll look at that reference. So now, if we open up our level blueprint afterwards, you can see when I highlight the value, or even if I highlight the variable, you can see it says current value is equal to cube, and it goes to its location, and at the very end, it's underscore 0. The underscore 0, you will see this a lot with actors, and what underscore 0 means is it's the first instance of that actor. If I had 10 of these cubes, we would probably have underscore 0, underscore 1, underscore 2, but it's good to recognize that this is specifically referencing that specific cube. So what we can do now is that since we have this stored as a variable, we can start manipulating with this cube whenever we want to, at least inside of this level blueprint with that reference. So one thing, let's actually change over. We made a overlap box before, and that stopped the spinning of our cube. If you remember our code, we had on component begin overlap, casted it to our first person character, and we stopped the spinning. Let's go ahead and delete that code, and let's get rid of that overlap box. So now, no longer we don't have an overlap box around the cube. It won't stop spinning when we get near it. Let's move that code over to our level blueprint. So what we can do is that instead of using an overlap box inside of our actor, on the top left here, where we can grab things into the world, we can type trigger, and you can see we get a bunch of different triggers. Let's use a box trigger. So let's make a box trigger. Let's drag it into the level. Let's just put it over into the corner so we know where it is. And then I'm going to hit R. You can see if I hit W, E, or R, we can cycle through our different styles of transforming an object. And let's just grab it along the X and the Y in between, and when we drag, we can widen it. So we know in the corner of our level to our right, we have an overlap box. Let's actually make that Y a little bit bigger, just to grab it in there. Let's drag it over. So now we have this huge area. So now, with this overlap selected, if I go back into my level blueprint, if I right-click, we get some references here. instead of doing like create a reference to trigger box, you see we have add events for trigger box. So I can do the drop down, and you can see under collision, we get our overlaps. We have our add on actor begin overlap. This is a lot like inside of our cube actor when we did an overlap there. And now we can check on our other actor. Well, let's actually not do that. We're not going to overlap with our player. Let's not do that quite yet. We'll do that in a little bit. Let's take our cube reference that we made a variable right here. So we set it at the beginning of the game. We spawn the cube and we store our reference. Now on begin overlap, let's use that reference we're storing and let's set spin to be false. And if you weren't here for the previous video, that spin boolean on tick, we're checking it. And if our spin is equal, spin question mark, we're asking ourselves a question. If it's true, we're spinning our box. If it's false, we're just not doing anything. So now let's check that out. On overlap, let's set the spin of our cube to be false. So we hit play, we can see it spinning, and now if I walk over into this corner, you can see our cube stopped spinning. So that's pretty cool. We can now interact with an object in the world from somewhere else other than inside of that actor. And that is something that you will be doing in 99% of your code. A lot of things you don't call from within the actor itself. A lot of communication has to go down. If you're doing any type of game with any sort of complexity, there's going to be a lot of communication going on between different actors in your world. Here, we're going from the level to an actor, but in a minute, I'll show you how we can go actor to actor, and I'll show you a different way to do that. One distinction I do want to make. Remember how I told you, this reference is to a specific actor. So if we actually messed up our code, let's unhook this variable. So now what we actually have is on the beginning of the game, we spawn our cube. Let's actually just straight up delete that so it doesn't cause any confusion. At the beginning of the game, at the beginning of our level, we're spawning our cube. And then when we walk into that trigger box, we're going to set spin to be false of the reference to our cube. You'll remember a second ago, we were setting that reference. Now when we delete that, we're no longer setting this variable. So literally, if we highlight the variable now, it'll say current value is none. That's going to stay true. So if we play the game, we're no longer setting this variable to be something. It doesn't know. So our cube reference is literally just null, it's void, it's none. But in the world, we do have a cube. So when we walk into this overlap box, you'll see it doesn't stop that cube from spawning. The reason being is that, as I just did, we're not setting this variable. You can see this variable is a cube reference, it is a cube object reference, and previously that was stopping our cube from spawning. But now, since we don't have this variable promoted to be a direct reference to that cube, we took that part away, it doesn't know what cube it needs to be interacting with. It's like, hey, you're telling me to interact with a cube, you're telling me to stop something from spinning, I don't know what you need me to stop spinning. And if we hit stop at the top here, we'll actually get an error. Unreal will actually come back to us and say, hey, there is a warning while playing in the editor. And if we open up that warning, you can see there's going to be a lot of text here. We can basically read it as, while we're playing the game, we access none while trying to read that cube reference. And it's going to say, we're trying to set spin to be false inside the event graph of our map with the description of, we access none trying to read that variable. So once again, what I'm trying to show here is that our actor references are to specific actors. We can't just create a variable of a cube reference and then expect it to work. We have to make sure that here we're setting that reference to be specifically to this actor we're spawning. This return value, once again, is to that specific actor. I'm repeating myself because it was something that was a little difficult for my friends to understand. Like, to me, I thought it was obvious, but for them, there's like a logic jump, and they're like, oh, I didn't realize that that was only to that one cube. So that's what I'm really trying to hammer home here. These references are to specific actors. You need to make sure that you are setting them or that you are getting references. You can't just create a variable and set it to be to a cube and just do an actor object reference and expect it to work. You have to make sure you're setting that reference. And one of the big hurdles of making games that you actually have to consciously think about, something I do all the time, whether it's an RTS, an FPS, a strategy game, one of the things before I write some code, I'm like, how do I want to get this object reference? So let's actually stop this from spinning in a different way. Let's actually do it somewhere else. So let's actually open up our player code. So if we click on our player right here in the world, we can do edit, open the blueprint for our player. let's actually shoot the cube. Let's make it so that when we aim at the cube and we click, we will stop it from spinning. One of the very, very useful ways of getting actor references, because once again, that's what we are doing in this level blueprint. When you spawn something, you get an actor reference. That's like one of like the biggest things you will learn in video games and making video games is actor references are king. Actor references are like everything. It's really important. A lot of what you think about is how am I going to get that actor reference. Here, when we spawn, it's one of the simplest ways. We get a return value. We get that actor. However, but now we're in our player. So if we go into our player code, we can't just grab that variable from our level blueprint. We can't do that. So now we have to think, okay, if I want to manipulate that cube now, how do I want to do it? Well, I know personally I want to aim at that cube and I want to make it so that when I click, when I use our fire event, I want that cube to stop spinning. So I'm going to use a really powerful tool called a trace. The most popular one is a line trace, but if we just simply typed in trace, you will see there is a lot of traces. You have your box, capsule, line, multi-box, capsule, line, sphere. You have a bunch. For us, we just want a line trace. And let's do line trace for objects. Or actually, let's do... yeah, we'll do that. So once again, I said it in the previous video, I don't want the calculation part of this to be what's really important to you. I want more of the reasoning to be important. So I'm going to do some math here. I don't want you to just like struggle on it. I really don't want that to be the focus here. But what I'm going to do is basically we're creating a line in the world. We'll visualize it in a second. We're creating a line in the world, and we're saying from here's the start of the line in the world. Here's the end of the line. Did we hit anything in that space? Did we hit something? And when we hit something, we can do some really powerful stuff off of it. So what I'm going to do is I'm going to get our forward vector of our actor. Once again, I wouldn't worry much about the math. I'm going to multiply it by a float to extend it. Let's make it 500 units long. And I'm going to add that back into the actor location of our self. That will give us our endpoint, and our actor location will be our beginning point. And then the other important thing that we want to make sure we do is we need to hook up the object types. And if we check our cube and we check its collision, I believe it's just a pawn. Let's see, or actually is it world dynamic? It is a world dynamic. Let's do world dynamic, and now what this will do is we can visualize it, we can debug, we can make it persistent. Debug means, do you want to draw this in the world? Draw debug is literally we're drawing something in that space to be able to visualize what we're doing. So now, when I click, we're going to do a line trace. So when I start the game, you can see here, I'm drawing lines when I click. These lines are really, really powerful. You can see, like, if I walk up, actually, if I hit our cube, do you see how it turns red and we get, like, a red box where it hit and then it turns green? That's the debug way of saying, hey, we drew a line. Up to this point, we didn't hit anything. Where we're drawing, you can barely see it. Where we're drawing, like, this red box that's kind of disappearing into the cube, that's where exactly we hit an object, and then the green afterwards is just saying, hey, we successfully hit something. This part's just green. Don't worry about it. That's really what's going on there. But what we can do when we hit something, when it says, hey, we have an impact location, we hit something, we can do some cool stuff. So off of a line trace, we get a Boolean, and you can see it says true if there's a hit, false if there wasn't. So let's do a branch. Usually you do branches after traces, and you're just going to do this so that off of true, when we do hit something, we want to launch some code. But this blue pin is the magic. This right here, a hit result. You will use these a bunch, pretty much no matter what game you use. And what we can do is if we drag it in space and we do break, it gives us a lot of information. It gives us some booleans, it gives us time, distance, location, impact, the normal. But the one that we care about right now is our hit actor. So what we can do is literally we get an actor object reference. I just told you about in the level blueprint, when we have an actor reference to our cube, we can manipulate it here inside of our first person character off of the line trace. We also can get an actor reference. But there's an important distinction to make. If we highlight our actor reference, it says hit actor. It is an actor object reference. If we go back and we highlight in our level blueprint where we spawn the cube, on the return value, it's a cube object reference. Very important, the difference there. This is specifically a reference to a cube, while this is, well, sorry, in the wrong place. Inside of our hit or line trace, it's only an actor object reference. So in our level blueprint, we could drag off this cube reference and we could do stuff like set spin. We could call our functions that were called like spin event, spin function. if we take a line off of our hit actor and we type like spin, there's nothing there. The reason being is that this code, we're writing it before we ever try to do a line trace and hit something. We're writing this code before the game knows what is going to happen. So really what the game is telling us is that it doesn't know what this hit actor is. It doesn't know if this actor is going to be another player, if it's going to be the cube, if it's going to be pizza. The game doesn't know what it's going to be. So one thing we can do to help give it a nudge in the right direction is that we can cast. And what we can do is we can cast to our cube. So we used a cast in the previous video, and really, if you remember, what the cast was is we said, hey game, when we run this code, this actor right here, this actor reference that we get, does that happen to be a cube? If it's a cube, this top pin, we will be able to run some code. But if it says, hey, no, this is not a cube, the cast failed, we can run different code. But the really important thing to us here is that now when we highlight this end blue pin that we get a cube object reference. So you can look at casts as one of two things. We can say, hey, we can use like a cast as kind of like a branch almost. We can say, hey, is this a cube? If it's a cube, let's run some code. If it's not a cube, let's run some code. Or you can also, like it's an and or situation, you can also use casting to change just a normal vague actor object reference into specifically our cube object reference. And now with this object reference, we get access to everything inside of our cube. Here we want to just manipulate the spin variable. So let's set that spin to be false, and voila, with this blue pin, we can now manipulate the cube. And now if we launch our code, we can click and look at what happens. We hit our cube with the line trace. With that line trace, we asked the game, hey, is that a cube? We passed in, kind of like you can see in this hit actor, it sees that it is a cube. Like it's like, hey, yeah, this thing's named a cube. It seems like a cube. Then when we cast it, we can change our object reference into a cube object reference, and now we can set its variables. So just like we did with the overlap, where here we had our object reference because we happened to spawn it in the level and we used it, here we're instead doing a line trace to get our actor reference. There are several ways to get actor references. The most important ones to me, personally, that I think you should understand are spawning. Where is that in our level? Spawning, off the return value, you get an actor reference. Inside of our first person character, when we do a line trace, we get an actor reference. There is another way of doing this. If, say, in our level, we didn't want to promote this to a variable, let's just say we did want to use this variable for a cube reference, but actually no, let's do this a different way. Let's say we don't have a reference to our cube. Let's say, man, we want to manipulate our cube, but we don't have a reference to it. A very expensive way of doing it would be to get all actors, sorry, I typed that wrong, get all actors of class. You can see this is one of the few nodes in Unreal that comes with a warning. If we read it, it says find all actors in the world of a specific class. This is a slow operation. Use with caution. Do not do this every frame. It's basically telling you, don't use this on tick. You will be destroying your own game. But what we can do is we can use it for example purposes, and then I'll show you more of a realistic way afterwards. But here we can say get all actors of our cube class. And then what happens is that it gives us an array of cubes. Really, we only want the first one. Since we only have one cube in the world, we know there's only going to be one, and index 0 is going to be our cube. But then you can see with this actor reference, we're getting all actors of our class cube. And then if we get out the first one, which will be index 0, you can see it's a cube object reference. And then once again, we can set spin to be false. So here, instead of the level blueprint, instead of using the reference we get off the spawn, we're going to use a reference from the get all actors of class. So now at the start, if I don't shoot the cube and instead I walk inside of our overlap box, you can see instead of it's using the spawn reference, we're getting all actors of class. And you can see if I highlight the array, it just says there's one thing in this array at index 0. That is our cube. Voila. So pretty powerful. This is not super expensive, but this is one of the more expensive nodes you will ever probably use. This is not a good way of doing it. The right way of doing it would just be like we had it before, of set the object reference and then call that object here, and that now with that variable set, we can set spin, and voila, we get the same result much cheaper. I guess I should back up one step. For those of you that weren't in the first video, we made a overlap box over in this corner. This overlap box is basically, if we walk into it, we are manipulating the cube. I don't believe I touched that in this video yet, so I apologize if you didn't see the previous one. So how would we realistically use the get all actors of class? Sometimes I will use these actors in the world where I will only have one of them. Sometimes I will create actors, invisible actors in the world. This is actually really common, is that you might make a new blueprint, you'll make an actor. This actor will never be seen, it will never actually move in the world, but its purpose is to do some type of calculation. I'll often do this for spawners. So say in my game I want to spawn a bunch of zombies. What I will probably do is I will make a blank actor that will never be seen. I just need it to be existent in the world, and that inside of this spawner, maybe like on tick, I can do spawn actor from class, and that if I had a zombie here, I could name it a zombie, and I could just start pumping out zombies. Oftentimes, I will do this in invisible actors. I apologize that now my friend is messaging me penis. He does not realize he's going to be in a video. But really, what that means is that say inside of like our character, we needed to manipulate that spawner somehow. One thing I could do is that on begin play, I could get all actors of class, and that I could name this spawner. And that then, with this get all actors of class, since I know I'm only going to have one spawner in the world, I could get the 0, I can promote it to a variable, and now inside of my player, I will always have a reference to that zombie spawner. The reason being why I think this can be an okay way of doing it is because, once again, events are important. Begin play. This means that this event will only happen once at the beginning of our actor existing. We will get all the actors of spawner, since we know we're only going to have our one zombie spawner. At least I would know I only have the one spawner. We can get it out and we can promote it, so that now whenever I'm working with my player and I ever need to maybe do something with the spawner, I can interact with it and I will always have that reference. This is a way of doing it. I would avoid doing this if you can. If you, like, say with that cube, how we were doing the line traces to stop it from spinning, if we wanted to achieve the code, this would be the way of doing it. This is a way of checking to make sure we're aiming at the cube, it's making sure we're hitting the cube, and then we get our reference to interact with the cube. This is a million times cheaper than get all actors of class. I'm probably exaggerating with a million. It might be 100, 1,000. It might be a lot more realistic, but this is a way of doing it. Begin play and getting all actors of class. If you know you're only going to have one of something and you just need to get a reference, that is a way of doing it. Some other things you might do is that if I am using, say, my game state, I could do get game state. If you don't know what a game state is, don't worry about it too much. But if you are using, say, your game state or your game instance, what we could do is we could cast this to our game state, and then with this reference, we could promote that to a variable and we could name it game state. So that now inside of my player, if I ever need to interact with my game state, I now will always have a reference to it. This is pretty cheap. We only have to do this once. We have to do it once at the beginning of our actor existing. It's pretty great. So there's a bunch of different ways to get actor references depending on what you need. I guess here's another one. When we created our HUD, let's hook this back up. In the previous video, we created a really crappy HUD. We just added it to our viewport. You can see in text it says this is a HUD. If we wanted to interact with our HUD, say we wanted our HUD to be health. So let's find our HUD again. You can see we have it here. Instead of this, let's name it health. Let's call this health, and we'll name it like... Actually, let's create two text boxes. One text box will just be health, and that we will copy paste, or actually we'll just create another one, and we'll just pretend like this is a really fancy HUD, and this one we had our health number. What happens that during the game, we want to interact with our player's health. One way that we can do it is that when we, just like we spawned the cube and we got a return value, here we're spawning a widget and we get a return value. We can promote it to a variable and we can say this is our HUD reference. And now, with this reference, we can manipulate our HUD however we want. I'm going to do one little thing. If you haven't interacted with HUDs, this is slightly important. We need to actually select this text actor. We need to say in this top right is a variable, and we can rename this our health. And now, if we compile, now what this actually did is that made this text box be a variable so that we can manipulate it. So now, if we go back to our character, let's actually make it so that instead of doing line traces when we click, let's lower our health. Let's pretend that when our player shoots, it hurts himself. He's masochistic or whatever that word happens to be. Now with our HUD reference, just as I made this variable called HUD, we can go here, we can do get health, and now you can see we have a reference to health is a text object reference, and I just happen to know we can use something called set text. And actually, what we're going to do is we'll just set our health to be 50. We're just going to do it once. If we wanted to, we could get the health amount and then subtract it. Let's not go that complex. This is just for example purposes. So at the start of the game, our health will be 100, and that when I left click, health becomes 50. So you can see we interacted with our HUD. The only way that we could really interact with our HUD is if we have a reference. When we spawn the HUD, this is how usually you interact with your HUD. You can get a reference when you spawn it, and then you set it to a variable so that later we can then go down and we can grab our HUD reference, and you can see the current value is equal to player HUD underscore 55. The HUD values or widget values always get really weird. It's 55. I don't know why, but you'll see it's an exact reference. All I really did, I wouldn't worry about it too much. I made that text box a variable, but really we could interact with that HUD now whenever we want, at least inside of our player. So that is pretty cool. Let's see, is there anything else we want to do with actor references? I don't think I'm missing anything. I think we did a pretty good job there. Know that there are a bunch of ways of getting actor references. The normal ways are spawning, are on line traces. If we go back into our level, you can see on our overlap, we get an actor reference. Just like our line trace, with the overlap, you can see we get an other actor reference. And if we wanted to, let's actually manipulate that HUD again. So with this other actor reference, this is the actor that overlaps with our overlap box out over here. Let's make it so that when our player walks into this overlap box, let's manipulate that HUD again. So if we want to, let's go into our character, let's delete our code that changed the text of our HUD, and let's make it so that when we walk into that overlap box, let's manipulate our HUD again. If you remember, this will be like a little pop quiz. This actor reference, it's not our character reference, right? This is our first person character. This is a vague actor reference. It's just a vague actor object reference. We need to make that into a first person character reference. How do we do that? We cast. So we can cast it to our first person character. And now, with our first person character, we're asking the game, hey, something walked into this overlap box. Is it our first person character? If it is, now we get a first person character object reference, and what we can do is we can actually go one step further and we can get our HUD reference. This is going to be a little trippy. So from our level blueprint, we get our first person character reference, and then from our first person character reference, we get our HUD reference, and from our HUD, we can get our health again. And now, like we did before, we can set the text, and let's set our health to be 1. We'll set the text box to say 1. So at the start of a game, we're adding the HUD. Our health is 100. When we walk into the overlap box, our health sets to 1. Reason being is that overlap box, we walked into it, it said, hey, an actor walked into this. It just happened to be a first-person character, or we only get a vague actor object reference. We say, hey game, is that a first-person character? It's like, yeah, that is a first-person character. So we can get a first-person character object reference, our actor reference. With the actor reference, we get access to all of our variables. We just happen to have a HUD variable. Now we can get our HUD, and then inside of our HUD, we have a text variable called health. We can get the health, and then we can set its text. Voila. This is the language of coding. Actor references are how your game works. I could not imagine making a game without actor references. I don't think it would be possible. Like if I shoot a zombie, say I was making a zombie first-person shooter, if I shot that zombie from my first-person character, if I didn't have an actor reference, I don't know how in the world I would really make that zombie die. I can think of a few ways, but they would be really janky. Actor references, though, I believe the second most important thing for you to understand. I hope this was of help. I really hope that this makes sense. Casting is a way to convert object or actor references to be specific to what you need, but really spawning line traces or any type of trace, You can get all actors of class, be a little careful, and then there's a bunch more. There's a lot more creative ways. I think those are the most important, but really, actor references are king, and I hope I made that very clear. In the next video, we're going to go over the last thing that I think is really important for a beginner of Blueprints to master, and that is going to be vector math. If we go back to our first person character, I did some vector math here. If you don't understand vector math, this probably went way over your head, even though to me it's very simple. That's what we're going to be going over in the next video. I'm going to be going over very simple vector math that you will be using a ton when making your game. You need to understand it, or at least on the very basic level understand it. That's what comes next. I hope you guys stick around for the third video, and I will see you guys there.